Good morning, students. Is my voice and board is it appearing clearly? You write in the chat box. Students, whenever while teaching, if you will get the doubt, okay, immediately you can ask me. Okay, immediately you can ask. You write in the chat box, and then I will clarify immediately. And whatever the line, whatever the step, if you not understood, कोई भी step आपको समझ में नहीं आते तो, then whatever the step if you not understood, okay, then immediately you can write in the chat box. I will answer for your question and I will explain once again. Okay, don't worry. Okay, right. I'm going to start now. Is it clear, students? The board is appearing clearly now. Okay, right. And peer group leaders request your friends to come to the class immediately. Okay, right. In the last class, what we discussed? Do you know? We started the chapter work and energy. Right. Students, is my voice clear or not? Any problem in the voice? Okay, going to start the class. Right, listen very carefully. You should write in the chat box everything, whatever the problem you have while teaching. Everybody should write if you have the doubt. Okay, right. And today I'm going to continue the chapter that we started previously, that is the work and energy. Is it right? This we started already. And then that chapter I am going to continue now. And for that, let us see here. First, what is the work? We discussed already the definition of the work and everything. And what is the work? Can anyone write in the chat box? Work and energy is our chapter name. Write the definition of work, anyone? What is work and what is the formula for the work? What we discussed. What is the work? It is a product of simple definition is the product of force and displacement, right? It is a product of force and displacement. Write in the chat box. Okay. And the work we previously already we discussed. That is the work done is nothing but it is the product of force and displacement in the direction of the force. Just it is a simple definition is the product of force and displacement that already we discussed. The product of force and displacement. In the last topic also we discussed this one. Right? Product of force and displacement in the direction of force. Okay, displacement should be in the direction of force. The product of force and displacement in the direction of force. Simply product of force and displacement. Already I gave one formula. Can anyone write the formula for the work? Write in the chat box, students. Work formula you write in the chat box. Work formula you write in the chat box. And don't leave the class. Today we are going to discuss important topic. You try to stay in the class till ending. The work formula is, we know that this is a object, okay, and for this we are applying the force this side. For example, we are applying the force this side, but the object is moving this side. What happening it here? There is some angle between them. Force and displacements are not along same direction. In this case, in this case The work formula we know is Fs cos theta. Already I gave what is theta. Theta is the angle between the force and displacement. Theta is the angle between force and displacement. But here we are applying the force this side, but the object is going this side. Okay, this is for example lawn roller. It is a uh, just like this lawn roller. Okay, and this is a handle to pull it, and this will be rotates and moves forward. Okay, like this. In this case, the object is moving this side, that's why the displacement is this side, right side, but the force is applied this side. Okay, just simply this is a roller. Let us consider lawn roller. It is used to smooth the ground. At the moment, work is the product of force and displacement. But the force displacement Fs, we can write cos theta also, because here the force and displacements are not along same direction. We will take the special case that is if force displacements are parallel to each other. Okay, and force and displacements are along same direction. Force and displacements are along same direction. Force and displacements are along same direction. Okay, that means for example this is a block. Okay, ice block. Let us consider. We are we are pulling this side. We are pushing this side, right side. Okay, we are pushing right side, and when we push the right side, when we push the object in the right side, the object also going right side. Okay, right, object takes the displacement right side, it is going right side. That means here we are pushing right side and it is going right side. That means force and displacements are along same direction. Arrow mark you should follow. If you have doubt, you write in the chat box. Okay, don't hesitate. After completion of the whole class, don't tell that sir, once again you can repeat the total topic. Right, it is not at all good. If you have the doubt in any step, this step how you wrote, and this formula how you wrote, what is this theta, what is the test, why we wrote Fs cos theta, or like this any type of question if you have in the mind, then you write simply in the chat box. Okay, you write simply in the chat box, I will try to clarify your doubts. Okay, right. Now work formula we write is Fs into theta is what? Theta is what here? Angle between the force and displacement. Force is right side, displacement right side, no angle between the force and displacement. Here we can take theta is 0. You know theta is 0, angle is 0 because no angle between the force and displacement. If like this, there is some angle between the force and displacement, but here force and displacements are along same direction. Same direction means theta will write 0. Theta 0 right means cos theta what happens? Cos theta is the cos 0. Cos 0 value in the last class I gave it as 1. Then you will get Fs into cos 0. Cos 0 is 1, then we will get only Fs. That means simply we use the formula Fs when F and S are along same direction. Okay, in the ninth class you not have this formula Fs cos theta. In the ninth class you have only formula Fs, but for the sake of extra knowledge I am giving this formula Fs cos theta. Okay, actually in the ninth class standard no need to learn that Fs cos theta, just learn the Fs. That means product of force and displacement is called as the work, right? And can you tell at what situation the work will be 0? Students, write in the chat box at what condition the work will become 0. Work may be 0, positive or negative. Okay, remember it. Work may be 0, positive or negative. Work may be work may be 0, work may be positive, work may be negative, right? Work may be negative. When the work will be 0, when work will be 0, do you know, can anyone tell the 0 work when happens? When 0 work will be there? 0 work when it will occurs? What are the conditions for the 0 work? That is, the condition is that we know work formula is Fs cos theta. For example, I am not applying any force, then force 0 you write in above equation. When you write 0, what you will get? 0 into S cos theta, 0 you will get, 0 into something is 0. For example, second condition is that 0. I am applying the force, but the object is not moving. Displacement is 0. Yes, 0 you write. Yes, 0 you write means 0 into something is again 0 you will get. The next case I am taking that angle is 90 degree. You know that when angle is 90 degree, then the cos 90 will become 0. Cos theta is the cos 90. Cos 90 value is 0. I gave the values of cos in the previous class. Right? When you write this in above equation, then work is equal to fs cos theta. In that cos theta you write as 0. When you write cos theta 0, 0 into fs we will get as 0. That means in the following three cases the work will be 0. Right? आप किसी ऑब्जेक्ट का ऊपर में फोर्स अप्लाई नहीं किया, वर्क 0 हो जाएगा. आप फोर्स अप्लाई किया बट ऑब्जेक्ट नहीं मूव नहीं किया हुआ, means object not moves. You applied the force but even though the object not displaced. For example, you are applying the force on the wall, you are applying the force on the wall but the wall not displaces. Displacement of the wall is 0, wall not moves. Okay, that's well, displacement 0, work 0. So theta is 90. Theta means what? Theta is angular in the force and displacement. Theta is angular in the force and displacement. According to the physics, then we have to do the work. For example, a person is carrying the load, a person is carrying the weight on his head and he is walking right side, then the displacement of this block is right side. In which direction he will apply the force? Okay, he will apply the force on the block without moving down. He will apply the force in the upward direction, because this block applies the force on the head in downward direction. Its weight acts in downward direction. Our body will apply the force on in upward direction. In this case, what happened? What is the angle between the force and displacement? Right, force and displacement. Force is upward, we are applying without falling the block in downward direction. Then displacement is right side. Theta is 90. In this case, the work will become 0. That means a person is carrying some load on his head and walking horizontally, okay, walking to a side, then work done by him is 0. Actually, the thing is that I am telling some standard than the 9th class. Remember it. Okay, that's some extra points I am giving that are useful for your future. Okay, all right. If the object is going right like this, the displacement is right like this there, but the force is like this there, then the force and displacements are inclined at an angle 90 degree, right? Okay, now in this case the work will become 0. Next, when the work will be positive, when the work will be positive work, what is the positive work condition? The positive work condition is that if force and displacements are along same direction, if force and displacements are along same direction, displacement, are you understanding, students? Are you understanding? Write in the chat box. Anaditi, Devanshu, Rupnarayan, Brajmohan, respond. Are you getting my points? Are you understanding? Yes or no? Are you understanding or not? Write in the chat box. You can write in the chat box. Okay. If force and displacements are along same direction, if force and displacements are along same direction, what we can write? We can write if force and displacements are along same direction, we can write work as 0. No. Something wrong here. If force and displacements are along same direction, then we can take as work as positive. Remember it. Work is positive when if force and displacements are along same direction. That means what? You are applied the force to pull this object right side, but the object also going right side. That means the force and displacements are along same direction. Simple matter. Then the work will be positive. Can you give any example in that the force and displacements are along same direction? Do you know gravitational force? Earth pulls the objects in downward direction. You know, right? Work done. Devanshu Kumar. Zero work once again explain. In zero work, you see work formula. Devansh. Work formula is Fs cos theta. Okay, I am explaining. Work formula is Fs cos theta. This you know basic formula this one. इसमें फोर्स जीरो सब्स्टिट्यूट करो आप. फोर्स जीरो किसी ऑब्जेक्ट के ऊपर में फोर्स से अप्लाई नहीं किया आप, उस समय में कितना काम होगा, वर्क कितना होगा. वर्क करने के लिए, काम करने के लिए आपको फोर्स अप्लाई करना होता है. आप फोर्स अप्लाई नहीं करते तो वो काम जीरो हो जाएगा. इफ यू नॉट अप्लाई एनी फोर्स ऑन ए ऑब्जेक्ट then the work will become zero. You substitute force in this zero. Zero into s cos theta will become zero. But you are applying the force on the wall. For example, I am applying the force on the wall. I am applying the force on big stone. Okay. Only I am applying the force on a truck to move. Then truck displacement is zero. Wall displacement is zero. When the displacement is zero, you substitute here, work will become zero. Then third condition where the work will be zero, if theta is 90 degree, then also work will be zero. These are the three conditions. If force zero, displacement zero, angle 90 degree. Angle 90 degree means what happens? Angle 90 degree means, I gave this example that you are carrying a suitcase on his head. Okay, you are carrying a suitcase on his on your head, and you are walking right side. Then the displacement is right side, moving right side. But in which direction you will apply the force on the block? You will push the block in a upward direction without falling the block in downward direction. That means force is upward, displacement is right side. If force is upward, displacement is right side, then what is the angle between them? 90 degree. Theta we write as 90 degree. Cos 90 value is 0. You remember it. You learned in the higher class, not now. Actually, in this class, you are not have the angle concept. I am explaining extra for you. Angle theta is 90 means cos theta. Cos theta what we don't know. We don't know. Just you remember cos 90 value is 0. Right? Cos theta, cos, sin, tan, like this it will be there. You will learn in the higher class. Just you remember it. Cos theta is angle. Cos cos you read. Cos theta is angle. Cos 90 value is 0. Here theta is 90. When cos theta 90, cos theta is cos 90 0. If you substitute here, then work you will get is 0. Work you will get is 0. In these three cases, if force 0, displacement 0, angle 90, we are getting the work 0. That means these are the conditions for the 0 work. What are the conditions for the 0 work? 0 work conditions are force 0, displacement 0, angle 90. In these three cases, the work will become 0. What are the conditions for 0 work? F0, S0, theta 90, then the 0 work will be 0. Have you understood? Devansh and others, write in the chat box. If force and displacements are along same direction, right? You apply the force right side, and object also moves right side. Right? The work displace, then work is said to be positive work. Work is positive work. Then work done by gravitational force. Work done by gravitational force on freely falling body. On freely falling body is positive. Is it right? That is positive. Why? Why it is positive? Can anyone answer? How it will be positive? How it is positive? Can anyone write? You peer group leaders motivate other students to come to the class. Work done by gravitational force on freely falling body. Freely falling body is positive. Right? Why it is positive? Can anyone explain it? Why it is positive? When it will be positive? You write. You note the chart screenshot. You note the screenshot and write in the chart notes. Okay. I'm going to continue now. Now, next one is I'm going to explain Positive work. How it is positive work? You see here, object is freely falling due to gravity. For example, if you release one object at certain height from the ground, okay, this is the ground. You release the object from certain height. You release it. You left it free. Then this object will goes down because of gravitational force. Earth pulls downward. The displacement also downward. Force and displacements are along same direction. Force and displacements are along same direction. When force and displacements are along same direction, then work will be positive. Okay. Then work may be negative also. When work will be negative. Yet what is the condition to make the work as zero? Okay. Work is negative. Sorry, negative work. Negative work condition I am going to explain. When the work will be negative. When the work will be negative. If force and displacements are opposite direction. If force and displacements if force and displacements are in opposite direction, force and displacements are in opposite direction, then the work will be negative. Then the work is negative. What is this? Force and displacements, how they are in opposite direction? Is there any possibility? Right? Force is one side and displacement is other side. Can anyone give the example for this? Force and displacements are in opposite direction, then the work is negative. Okay, I will give the example for this. For example, a ball is moving on the ground. Somebody in the beginning he applied the force. Somewhere the person applied the force. And here the ball is moving on the ground. For example, initially the ball is moving with certain velocity. After some time the ball comes to rest. Ball final velocity will become zero. U is the initial velocity, V is the final velocity. Ball is moving on the ground. Ball is moving. Saraswati Matav, when the force is applied on the object and the object displaces along the direction of the force, then the work is positive, right? You write in the chat box. I will read and I will answer for any question. Okay. Right. You see here force and displacements are in opposite direction. Then the work is negative. For example, the football is moving on the ground with some velocity. After going certain distance, it will come to rest. There is some retarding force in this case. Do you know retarding force? Retarding force means what? That force tries to stop the object. Okay. Actually, the ball is moving on the ground. It cannot go continuously. After going certain distance, it will come to rest. Ball is moving on the ground. It will not. Ball is moving on the ground. After going to certain distance, it will come to rest. Why it will come to rest? Who is stopping that one? That is a frictional force, resistance force. That resistance force is called as a frictional force. That will be acts left side. But the object is going right side. That means the displacement is right side. Object is going right side. But the retarding force, the force which tries to bring the ball to rest, that force is the retarding force. Okay. The work done by the retarding force on moving object is negative. Work done by retarding force. Work done by retarding force on work done by retarding force on moving object is negative. Why? Retarding force is opposite to displacement. Retarding force means it opposes the motion of object. It opposes the motion of object. Okay, I will give one more example. For example, this is the slope. For example, the car is going down without car is going down due to the slope. Okay, it is not started, engine not started, but its displacement is downward. You are applying the force this side. You are trying to stop it. You are trying to stop it. You are trying to stop it. But even though it is going in downward direction, because the displacement is this side, the car is not stopping, but you are trying to stop it. Then the force is this side, displacement is this side. Force and displacements are in opposite direction. When force and displacements are opposite direction, na? One is this side and other is this side, means opposite direction. In that case, the work we can take as negative. When the force and displacements are along same direction, Force displacement same direction means work positive. If force displacement is opposite direction means work negative. Understood? Right. Students, are you getting my points? Write in the chat box. Next. Next topic is the energy. Right? What is energy? What is energy? Do you know the definition of energy? What is energy? Energy is the capacity to do work. The capacity to do work is called as energy. The capacity to do work is called as energy, right? If you have the capacity to do the work, then we can say that you have the energy. Is it right? There are different forms of energies are there. Heat energy, light energy, mechanical energy, sound energy. There are various forms of energies there. If you have the capacity to do the work, then you have the energy. That means if you are not doing the work, that means you are not have the energy. According to the physics, energy is equal to work. The capacity to do work is called as energy, right? If you have the capacity to do the work, then you have the energy. If you will do more work, then more energy will be there. If you do the less work, then less energy will be there. The work and energy are equal. Okay. And then in our ninth class, there are one we are going to discuss about the one type of energy that is called as a mechanical energy. Mechanical energy is two types. Okay, remember it. Mechanical energy is two types. The first one is the kinetic energy and the second one is the potential energy. Kinetic energy and potential energy. Kinetic energy and potential energy. And what is kinetic energy? Let us discuss about the kinetic energy. And which body has the kinetic energy? Moving body has energy. Do you know? Lorry is moving, one block is moving. Okay, anything, any moving object has energy. Is it right? It will do the work also. For example, anything, any object for a we will do little activity for this. Let us see here. This is a small cart. Okay, and this for this we are one side we are taking the pulley. This is pulley. Okay, and at the other side we are hanging some weight box at here. Here I am placing the one wooden block at here. I am placing the wooden block at here on the table. This is a table. Okay, here some block I am keeping to stop it. Just when you remove this block, what happens? Due to this weight, this will goes forward direction. Okay, this will goes forward direction and strikes the another body, right? This is a moving object. It strikes this body. Then this body is also moves forward. Is it right? Because of this, that means what it is doing, this moving body applying the force on this body and it is making to displace this one. That means this body pushes this side and this body moves the right side. Okay, when you release this block and you add more load and then this starts motion and it strikes this block. Due to that, it applies the force on this block and this block will be moves forward. That means this moving object is doing the some work on this. Is it right? That means this moving object has energy. That energy is called as kinetic energy. Kinetic energy is nothing but the energy possessed by the moving object. Energy possessed by a body by virtue of its motion. That means due to motion, if any body has energy, that energy is said to be kinetic energy. Right? Energy possessed by a body means energy have a by a body by virtue of its motion is called as kinetic energy. Kinetic energy Kinetic energy is nothing but moving object has energy, that is a kinetic energy. Simple it is. Okay, the energy have by the moving object. Due to motion, if body has energy, that is called as the kinetic energy. Right? And moving object, which one has the kinetic energy? Moving object has kinetic energy. Moving object has kinetic energy. Kinetic energy simply we can also write Ke. Ke is the kinetic energy. Moving object has kinetic energy. Moving object has kinetic energy. Can you give example of any moving object you can give? Right? Moving vehicle has kinetic energy, na? Is it right? And flow of water also has kinetic energy. Flow of water, this is also moving object. Is it right? And rotating fan also has kinetic energy. Is it right? These are all moving objects. These moving objects, these moving objects has kinetic energy. Okay, this moving object has kinetic energy. Actually, we are discussing in the straight line motion. That's why we should not write this one. Okay. Now you take the screenshot and note it. Is it clear, students, till now? If you have any doubt, you write in the chat box. Niharika, yes. Okay, good. If you understood, let us continue. We will derive the formula for the kinetic energy. If you have any query, okay, you write in the chat box. Don't hesitate to write in the chat box. Okay, be patient and listen very carefully. Important topic we are discussing. Next, I am going to derive the formula for the kinetic energy. Remember it. I am going to derive the formula for the kinetic energy. Expression for kinetic energy. Formula is said to be expression. Okay, expression for kinetic energy. Expression for kinetic energy. Expression means a formula I am going to derive. I am going to derive the formula. Expression for kinetic energy. Consider an object of mass m. This is the object. Okay. This is an object. It's a ball we can consider. A bird flying in the sky. Right. Good. And now this object mass is m. It is moving with certain velocity. For example, this object initially at rest. This object initially at a rest. Now we are applying, this object is initially at rest. Now I am applying some force on this object. Okay, I am applying some force on this object. When we apply the force on the rest object, what happens? this rest object will comes to the motion. Is it right? It starts, it takes some displacement and it goes to somewhere here. At this location, it has some velocity we can consider as the v, final velocity, and the mass of object is m. And before applying the force, the object is at rest. And after applying the force, the object starts motion and it acquires some velocity v. And now in this case, what we are going to do it here, right? Listen it here. We are going to derive the formula for the kinetic energy. Here, you see here, we are applying the force on this object. The object is displacing. That's why we are doing some work at here. That work will be stored in the form of kinetic energy. That work will store in the form of kinetic energy. That work we have to write it here. For that, what we have to do it here? The work done to move object, right? How much work we are doing to move this object? The work formula is Fs, force into displacement. Okay, because the force and displacements are in the same direction, we write Fs. But here the work will be stored in the form of work done to move object is the Fs. But we know force formula in terms of according to Newton's second law. Can anyone tell the force formula according to Newton's second law? Write in the chat box. Right. Okay. Force is Ma. F equal to Ma we write. W equal to MAS we will get. W equal to MAS we will get. But one thing we have to do it here. But there are three equations of motion, you know. Okay, this is considered as equation 1. There are three equations of motion, right? But according to the third equation of motion, do you know what is third equation of motion? There are these equations we discussed in the motion in a straight line chapter. You know V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to AS. In that, I am going to use the third formula. What is the initial velocity in this object? We write the third formula. What is the third formula? V square minus U square is equal to, we write as 2as. This is the third equation of motion. But in the for above diagram, initial velocity of the object is 0. Starting the object is at rest. After applying the force, the object acquires the velocity v and it is moving right side with acceleration a and takes the displacement s. From above formula, we write v square is equal to v square minus u we write as 0 because the object is at rest in the beginning and 2as. Okay, and we write that v square is equal to 2as. From this, as is equal to, we write as v square by 2. As is equal to, we write as v square by 2. This is equation 2. Now what we have to do it here? Equation 2 is substituted in equation 1. If you substitute in equation 1, then what you will get? W is equal to MAS. But AS is what here? AS is V square by 2. We are getting MV square by 2. Here we got work as half MV square. But the work will store in the form of energy. Okay. But the work store in the form of work done to move object. Work will store in the form of kinetic energy. In the form of kinetic energy. That means the work is only kinetic energy. What is the work at here? W, that is equal to kinetic energy. Then what you are getting here, kinetic energy, that is half mv square. Kinetic energy will get as half mv square because kinetic energy only work. Work is equal to kinetic energy. That means the kinetic energy is equal to work. Work is half mv square from equation 3. Let this you take as equation 3. This is the equation 4. We derived the formula for the kinetic energy. The kinetic energy formula is half mv square That means if m mass of object moves with velocity v, then its kinetic energy is half mv square, right? Okay, very good. Any doubt in the derivation in any step? Write in the chat box, students. If you have doubt, if you have any query in this derivation, you write in the chat box. Abhishek Kumar, due to earth gravity, object falls. Very good. Niharika, Saraswati, Nisha. Respond in the chat box. It was very nice. Deva. I will read your name also. Permanently will stay in YouTube. Whatever that you are listening it here, it will be stored in the permanently in the YouTube. You can watch in any time. Okay. After 10 years or so, it will be there. That is the thing. It is the benefit of this YouTube. In any time you can watch. Abhishek Kumar, once again repeat. You are asking to repeat. But what step you I have to repeat? Okay, within 2 minutes I will repeat. Okay, you remember. Work formula, you know Fs, you know. F formula, you know, according to Newton second law, mass into acceleration. You write here instead of F, ma. Okay, work is equal to Fs, you know. F formula, you know, previously in the laws of motion chapter. Okay, Newton's laws we discussed. F equal to ma, you substitute here, mas. Work is equal to mas, you are getting. And then after that, mas आने के बाद उसको इक्वेशन 1 लिखा हुआ, but this is the third equation of motion, you know that one. There are three equations of motion, v square minus u square equal to s. In that what you do here, initially object the ball is at rest on the ground. After applying force, it starts motion and it acquires the velocity. That's why initial velocity we wrote 0 in this. U0 you write. Remaining as these terms. V square minus U0 square is equal to S. We're getting the V square is equal to AS. Then 2 taken to left side. AS is equal to V square by 2 we will get. This is equation 2. Equation 2 substituted in equation 1. Here. M into AS. AS we got here. V square by 2. When these 2 taken to left side, we will get by 2 because 2 is multiplying the AS. When it comes to left side, it will divides. AS is equal to V square by 2. This we substitute in equation 1 because in equation 1 AS is there. Then W equal to M into AS. AS is what here? V square by 2. We substituted. In case of AS, we wrote V square by 2. M into V square by 2, you got work. Then after that, half mv square I wrote. But the work is equal to kinetic energy here because we are doing the work to move the object. We are applying the force. It is taking the displacement, and this work will convert into kinetic energy. This work only kinetic energy. That means in case of work, we write kinetic energy. Kinetic energy is half mv square. Understood? Abhishek Kumar. Okay, good. Right. Let us continue. And can anyone write the formula for the momentum? What is the formula for the momentum? What is the formula for the momentum? Can anyone write in the chat box? Can you write the formula for the momentum? Momentum formula is what? Oh, I am giving this in the note. Okay, note. Very good, Abhishek. Momentum formula is mass into velocity. Momentum formula is mass into velocity. Very good. And now You see here, one point I am going to give. Niharika, good. Note, right? Some point I am going to give. That is the momentum of object. What is the relation? What is the formula for the momentum? Momentum formula, you know. For example, m mass of object. It is moving with velocity v, and then its momentum is mass into velocity. Okay, and from this, velocity is equal to what we write? E by m we write. Can we write? M is multiplying V here. M is taken to left side. P by M is equal to V. V is equal to P by M. Okay. But the kinetic energy formula is what? You know, do you know? Half mv square. Huh? Instead of V formula, you write here from momentum equation. We write is P by M. P by M, V, P by M from above equation. This equation we got from above equation. And then we simplify it, half M into P square by M square we will get. Then let us simplify some more, that is P square by this M square will cancel, we will get P square by 2M. This is also formula for the kinetic energy, but this is in terms of momentum, where P is the momentum of body and M is the mass. P is the momentum and M is the mass of body. Okay, right. This is about kinetic energy. Kinetic energy formulas, we discussed two formulas, very important. One formula is half mv square. Okay, kinetic energy formulas. One formula is half mv square and another formula is p square by 2m. P square by 2m. Okay, these are the two formulas that we derived now. Yes, have you understood? If you have doubt, you write in the chat box. Okay. Next topic is the potential energy. What is potential energy? Mechanical energies are two types. I said kinetic energy and potential energy. And kinetic energy definition, kinetic energy formula we discussed. Then what is the potential energy? Then which object has the potential energy? The object which is at certain height from the ground. Due to its position, the object has energy. That is the potential energy, right? The energy possessed by object due to the energy possess means have, the energy have by a object, by a body or object due to, by virtue of means due to its, by virtue of its position or state is called as potential energy. Potential energy, what is potential energy? Due to position, due to state, if object has energy, then that energy is called as, right, potential energy. I will explain this one. I will explain. Okay, example. For example, water stored in a tank, overhead tank. Water stored in overhead tank. Water stored in overhead tank. Okay, has energy. For a stone is at certain height from the ground. A stone at certain height from ground has energy. Do you know this? For example, the stone is at here. Okay, this stone has energy. If it will fall on your head, then it will breaks your head. Is it right? That means this falling object which at certain height, then it has energy. When it will fall on your head, it will do the work. Right? It will apply the force on your head. It will breaks your head. That means this stone which is at certain height from the ground, it has energy. The water stored in certain height also has energy. Water stored in the tank. If you release that water, it will convert into kinetic energy. That potential energy convert into kinetic energy. Water stored in the tank, now it is not moving. It is at rest, but it is a certain height ground from the ground. That has energy. That is the potential energy. A stone certain height from the ground, it is also has the potential energy. Compressed spring, for example, stretched string, stretched or compressed spring. For example, use compress a spring. Due to compressed state, it has energy. For example, a spring is compressed in your hand and release it. It will fly. Why it will fly? Because after when you will compress it, you are doing some work to compress it. That work will store in the form of energy. That energy is the potential energy. That means due to compressed state, object has. This object is not moving. Compressed object, compressed spring has energy due to its state. The object which is at certain height from the ground, it also has energy. That is the potential energy. Have you understood? We will derive the expression for the potential energy. For that, for example, one object is on the ground. Okay, object is on the ground. We are lifting this object to certain height. You will do some work to lift it. Yes, you will apply the force in upward direction. Object also goes to certain height. Okay, it takes displacement in upward direction and goes to certain height h, right? And the object mass is m. Object weight acting downward direction. Okay, and we are doing some work to lift the object to the h height. That work will store in the form of potential energy. ओके, आप एक ऑब्जेक्ट को लिफ्ट करने के लिए कुछ काम करता है, उस काम उसमें एनर्जी रूप में स्टोर होता है, एनर्जी फॉर्म में स्टोर होता है. उसको छोड़ते तो फिर ये एनर्जी काइनेटिक एनर्जी तरीका कन्वर्ट हो जाएगा, फिर नीचे गिर जाएगा. दैट मींस हियर द एक्सप्रेशन इज व्हाट वर्क डन एक्सप्रेशन आई वांट. Again, the work done is equal to force into displacement. What is the force? How much force you have to apply it here? To move upward, the come say come you should apply the force that is equal to weight of the body. Minimum you have to apply the force that is equal to weight, gravitational force. Displacement, how much it is taking? It is going from here to here. Displacement is h. You write here work is equal to Fs formula. F is S mg. Mg force you have to apply to move upward, because with mg force the gravity pulling down, but you want to move it up. That's why you should apply mg force. Displacement is h. You write here work is equal to mgh. You will get, but the work will store in the form of potential energy. Work is equal to potential energy here. Okay, then we write here potential energy. This is work only potential energy. Then the potential energy formula is mgh. Potential energy due to height object has a potential energy. H is the height of object. If m mass of object at h height, then its potential energy is PE, is means potential energy, that is mgh. Kinetic energy formula is half mv square. Potential energy formula is mgh. You should remember it. Okay, today I am going to close the class. Thank you to all, and you write the notes. Okay.